Hello, and welcome to another installment of Geology. Wow. Not of wow, but surprise! Today, for this little short thing, I'm going to talk about the structure of the Earth. And I'm going to name them all off. That would be the crust, the upper mantle, the outer core, and the inner core. The crust is what we all walk on. It's a thin little shell around the mantle, and it pretty much is what everything we deal with. All the oil we pump out, everything we dig underground and we find is in the crust. The mantle is entirely too hot. The crust is generated through oceanic ridges or volcanoes, and then it is destroyed in subduction zones. So that's where the crust goes. When it goes under and goes into the upper mantle, and there it heats up drastically and can cause on land volcanoes, which is where like the Pacific Northwest, Ring of Fire, Japan, Mount Etna, where that stuff comes from. However, you also have volcanoes, and they're technically volcanoes like in the Atlantic Ocean, in the Mid-Atlantic Ridge, but we don't necessarily see most of the things they do, unless we talk about that one in Iceland. I call it Jafnadal, because every time I've had Wikipedia pronounce that name to me, I'm like, Jafnadal. So, you know, one time I said Jafnadal, but, yeah. So, when the crust gets pushed down, it melts and starts turning into little pockets for that. But the mantle is the thickest part of the Earth. And so, and it has convection currents in it, like you've probably heard about, that takes place on the sun. The convection currents create generalized hotspots, which are the Mid-Atlantic Ridge, the South Pacific Ridge, to an extent the Juan de Fuca Ridge, Hawaii, and the few supervolcanoes that happen to be around. Yellowstone, I think Krakatoa still is one. Those are hot spots, and that's where the convection goes up from the core out to the surface. They go back down, and that's where the subduction zones are at. So that's where, and like the Himalayas, that's another cool spot. That's another place where they kind of get destroyed, but they don't necessarily, the plates themselves can get destroyed, but they more or less just get merged with something else. Moving down into the mantle, which is high in silica content, that's on the periodic table, you can look it up. It's most plentiful, silicon and oxygen, most prominent minerals, elements in the Earth's crust. It forms quartz, as you probably heard me talk about in either my blogs or my previous Geology video. Quartzite, metamorphic rock. So, as we keep descending down, we actually hit the core, which is where the liquid starts, the outer core. The mantle is not liquid. It's still solid. It's ductile. So it's sort of like molasses or syrup in the refrigerator. It can, they move in convection currents, but over a long period of time. Whereas once you hit down into the core is when you start actually getting liquid. But it's incredibly dense because you have to have incredible amount of heat. And with all that earth on top of it, there's incredible pressure down there. So, yeah. Crazy cat. So, we've got that. And the outer core is liquid. The inner core is liquid also. Or, the outer core is liquid. The inner core is probably solid iron. It says here, the liquid outer core surrounds the inner core and is believed to be composed of iron mixed with nickel and trace amounts of lighter elements. And solid iron core, which makes sense because as the outer core whips around it, it creates friction, which generates an electrical current, because there's energy being created, because it's also, the mantle itself is very high energy, or the outer core itself is high energy, so it starts creating electricity, and that electricity starts flowing over the iron core, which then makes our magnetic field. So, you can thank the outer core for our magnetic field. And you call it dynamo theory. And so yeah, the solid inner core is too hot to hold a permanent magnetic field, but probably acts to stabilize magnetic field generated by the liquid outer core. So that's that. That's the structure of the Earth. The Earth is, several miles. It's like 8,000 miles thick, diameter, and starting at about 3,000 miles down, that's where the inner core starts. That's where the solid iron core starts. To give you an idea, about 3,000 miles on the surface, that's about the width of the United States. I believe that's like Portland to Washington, D.C., or Seattle to Washington, D.C. It might be about 3,000 miles, something like that. I may be completely wrong. I'm going off knowledge about Oregon Trail. So, yeah. That's that. Hopefully now you understand the structure of the Earth. I'll put a little link down to this little small section in the comments so you can read through it yourself.